All right, so you've been getting pretty good with shapes and positions in Python, huh?
Yeah.
Working with things like abs and distance, and even angle too.
Mm-hmm.
And even starting to wrap your head around how get point in dir works.
That's a good one.
That's a tricky one.
Yeah.
But it's so powerful for making things move around the screen.
For sure. For sure. I mean, once you've got that down, it just like opens up so many possibilities for projects and stuff.
Totally. And, when you think about it, like what makes games and simulations so interesting,
Yeah.
it's often that you don't know exactly what's going to happen next.
Right. It's that unpredictability.
Yeah, that element of surprise.
Exactly.
And that's where this idea of randomness in programming comes in.
Yeah.
And today we're going to look at a function called ranrange,
Okay.
which is like our starting point for introducing that randomness.
Yeah, this is like a fundamental tool for injecting that randomness, which is what makes things feel less predictable and more dynamic.
Right, and more engaging for whoever's using your program.
For sure. For sure.
So our mission today is to really understand how ranrange works.
Okay.
Some of the things we got to keep in mind when we use it.
Yeah.
And why it's so valuable, especially as you start building more and more interactive projects and stuff.
Exactly.
So ranrange, low, high.
All right.
What's the first thing we should know about this?
Well, it takes two integers as input.
Okay.
You've got your low value and your high value.
Right.
And it spits out a random integer that falls somewhere in between those two.
Gotcha. So it picks a number in between.
Exactly.
So for example, in one of the sources we were looking at, you were trying to draw a circle and you wanted the radius to be different every time the program ran.
Yeah.
So you might use something like range 20, 150 for the radius.
That's a great example.
Yeah.
Every time that line of code runs,
Right.
maybe when someone clicks or, a new round starts in your game,
Yeah.
it's going to randomly pick a whole number between 20 and 150.
Right. So it could be 20.
It could be 20.
Could be 149.
It could be 149. It could be 87.
Yeah.
Anything in between.
The variability comes in.
Exactly. And that's what makes it visually interesting, too.
Totally.
Yeah.
Now, if you wanted to display that random radius, maybe as a score or just to show the current size,
Yeah.
Yeah. The sources we were looking at really emphasized how you handle that random number.
Absolutely. This is super important.
Yeah.
So let's say you use new radius equals range, 20, 150, to get that random radius.
Right.
And you want to make sure, Bert, the circle that you draw and the number that's displayed on the screen reflects that same radius. What would you have to do?
You'd have to use that new radius variable for both.
Exactly.
Right. So you'd set the circle's radius to new radius.
Yes.
And then the text of your label to new radius as well.
Right. Because what happens if you call range twice?
Oh.
So think about this. You set the circle's radius to range 20, 150.
Okay.
And then on the next line of code, you set the text of the label to range 20, 150 again. What's the person using your program going to see?
They're going to see a circle with one size, and then the number's going to be totally different.
Exactly.
They'll be like, wait, what?
Right.
That doesn't match up at all.
Because each time you call range,
right,
it's going to spit out a new random number.
Right.
So storing that value in a variable is super important.
So you got to hold on to it.
You got to hold on to it.
If you're going to use it more than once.
Yeah.
Okay, that makes perfect sense.
Cool.
Now, there was another thing that the sources kept bringing up about range.
Okay.
That could really trip you up when you first start using it.
Oh, yeah. What's that?
And it has to do with that high number that you put in.
Right. The upper bound.
Yeah.
This is a common point of confusion.
Yeah.
So the golden rule here is that range, low, high, will never actually return that high value.
Okay.
It goes up to it, but it doesn't include it.
So if I write range 1, 3, what are the possible numbers I could get back?
You could get a 1 or a 2. You will never, ever, ever get a 3.
That's a little strange.
I know. It is a little counterintuitive, but there are some good reasons for it.
Okay.
It often makes things cleaner and easier when you're working with like lists or sequences where you start counting at 0.
Oh, okay.
It helps avoid going out of bounds. So it all kind of makes sense in the grand scheme of things.
In the context of like lists and indexes.
Yeah.
Okay.
Exactly.
So just to be crystal clear.
Yeah.
If I had range 50, 52.
Right.
What are the only two possible numbers you could get?
50 and 51.
Okay.
That's it.
52 is out?
52 is off the table.
Okay, so what are all the possible return values of range 2, 5?
2, 3, and 4. Never 5.
Right.
The high value is always excluded.
Got it.
Cool.
Now, the sources we were looking at also mention something pretty practical.
Okay.
Especially when you're doing coding exercises and submitting them to be like automatically graded. It's about how randomness can mess with those auto graders.
This is interesting, right? Because if your code uses rand range to like randomly place a character on screen or something,
right,
and the autograder runs your code and gets a different random position, it might think that your code is wrong.
Even if it's not.
Even if it's working perfectly fine.
Right.
So it can be a real challenge.
It's like if the autograder has a specific idea of where the character should be.
Yeah.
But your code randomly puts it somewhere else.
Right.
It's like, nope, that's wrong.
Wrong. Wrong answer.
Even though it's technically working.
Yeah, exactly.
So what they were saying is that...
Well, in a lot of these coding exercises where randomness is part of the challenge, the starting code that they give you will actually provide you with the random numbers in a controlled way.
So it's like predetermined randomness.
Exactly. Right. So that when the autograder runs your code, it gets the same sequence of random numbers every time.
Oh, that's so smart.
And that way it can test it consistently.
Okay. So big takeaway there.
Don't mess with the random numbers.
Yeah.
Don't change them. Don't remove them.
If it's provided in the starter code.
Exactly. It's there to help you.
Leave it alone.
Leave it alone.
All right, so let's do a quick recap of what we learned about rand range.
All right.
It's your go-to tool for getting random whole numbers. You give it a low and a high whole number, and it spits back a random whole number in between those two. But it never includes the high number itself.
Super important to remember that.
That's the big gotcha.
Yeah.
But now that you know about rand range, think about how you could use it with those other functions you've been learning, like distance.
Oh, yeah.
You know how to calculate the distance between 2 points and get point indir.
Right.
How could you use rand range to make those things even more interesting?
For sure. I mean, you could use rand range to decide how far an object moves using distance.
Or like pick a random angle.
Exactly.
Point angle too.
Yeah. Yeah. Or you could have things appearing in random spots using get point indir with a random distance. Like the possibilities are endless.
Yeah. You can add that element of chance and surprise.
To your game's animation simulations, make them much more engaging and replayable.
Totally. So here's something to really think about.
Okay.
Even though randomness in programming lets us build these like unpredictable and fun experiences, it's all based on rules that the computer's following.
Right.
And understanding those rules, like we've been talking about with Randry, is what gives you the power to actually control that unpredictability.
That's the key.
And create some amazing stuff.
It is.
And surprisingly complex things.
For sure. For sure.
So keep that in mind the next time you see something acting randomly on a screen.
Totally. It's all thanks to code.
Yeah. All right. Until next time.
Hey!